Hi, this is Ricky Sun. I'm a Pi consultant. In this video, I'm going to talk about what is the Pi interface for OPC DA. In the terms, right? What is OPC DA, right? OPC DA is OLE for process control. That's OPC. And then DA is data access. So that's the, definition for that. Why this is here? What I see is different system out there, right? The PLC, the DCS, the SCADA system. They all can talk OPC language because they are on different language. How do OSI, SOF, or FIFA get the data from so many systems? And luckily there is OPC there. So everyone create a OPC servers that can talk to their language. Then OSI Soft just have to create one interface to talk to the OPC server. Then they would be able to collect the data from hundreds of machines, different systems. That is very smart because you just have to create once and it works for many systems. But of course, there are many interfaces out there, and those interfaces are there because there may be no interface that talk to that system. That's why OSI Soft created, and then collect the data and then try to win the customer, right? So talk about like when I was in field surveys, I like to download MajorCon OPC server for testing. Like I go to the website, I download it. It's a free thing. I install it on my server, and then it is able to create OPC data from the OPC server, MajorCon OPC server. And I think there's alarming events and all that different thing that I could test as well. That's why I like it. I think I have to give it credit. It has helped me so much in the past when I was field service. I have to get it working before going to the field. We have limited time, internet resources. Maybe it's like remote and we don't have help. We cannot call. Then we have to rely on ourselves, getting confident. That's why we always have simulator testing before going on site, deploy for our customer. This is kind of like the process. I don't know if it is kind of the same with Alvifa now, but I think the people are still passing on this best practice. The other thing, interesting architecture I want to share also about Pi interface for OPC DA is there is a Pi OPC server, right? You can download that when you have license. What it does is to expose Pi data archive data through OPC protocol. By architecture in the past, like without MajorCon OPC server, I was actually creating a random interface sending data to Pi data archive, right? And then the data archive have the data, and then I use Pi OPC server to expose that random tag data from here, right? And then what I do is I use Pi interface for OPC DA to get the data from the OPC server and then send it back to the Pi server by creating another tag, right? Then the random tag and my new Pi tag would have the same data, right? It's kind of like a loop. So I got confused because it's kind of interesting when doing testing, getting familiar with the tool, right? So in the past I did that. Just want to share that with you so you can do the same. Maybe, right? You can play with that. If you have like Pi interface for OPC DA software, then you can play. And talk about the challenge about setting up Pi interface for OPC DA. The challenge most of the time is DCOM. Like when your architecture is you have the OPC server on one machine, and then you have your interface install another machine, and then you have another Pi server, so different machine. Then DCOM has to be configured, and DCOM vary, like configuration depends on system, different brand, different DCOM configuration. So this is a super challenging task in the past if we see this architecture. And what people or OSI solve, I think right now they have field surveys. Make sure before we go on site, we know what it is. If we see this architecture, we better know how to do that or get the manual or something. But what we could do is to avoid setting up this complicated DCOM by installing the OPC server with the Pi interface for OPC DA. If they are on the same machine, then it is way easier. Then we could use account that have permission on the OPC server to set up our interface. And then usually this will be successful, and we just have to create a trust, Pi trust in the Pi server, and then data would be sent. And also, if you want to create an interface instance, an interface for OPC DA, then you would need to use that tool called Interface Configuration Utility, right? ICU, that is like what it's kind of simplified way acronym call. We call that many times. And then configure that. And then, when I create the tags, what we see in the OPC server is the item ID. And what we need to create in the Pi server is a tag with instrument tag that links to the item ID. So that is the instrument tag is an tag attribute that you need to fill your item ID in so that both will link together and then collecting data. And other things about Pi interface for OPC DA is it only captures current data. So it doesn't go back to history. You could, however, how do you avoid data loss then, right? The only way you could do is to set up a pair, a failover pair. You have a primary, you have a secondary. When the primary is down, the secondary still send the data. That's one way to do it. I think that's the only way to do it if you have only Pi interface for OPC DA. That way you could minimize your data loss. One more thing about on the interface server as well. The reason why you want to bring that interface as close to the source, which is the OPC server, as much as possible, is because there is a thing called buffering. And the buffering is when there is a disconnection to the Pi server in the network, data won't be lost. And especially in this situation is OPC DA, right? So it's just the current data. You need to have some sort of mechanism to keep the data, and then when the network resumes, send the data back into the Pi server. That is, I think that's two things that you could utilize to make sure your data have like a steady stream instead of having data loss sometimes, right? And lastly, I want to talk about advice tag and pull tags. Advice tag is when there's an update to the OPC server, it will shoot the message to the Pi server through the interface. What if there is no update? I mean, it's kind of like flat. In that case, if you configure advice tag configuration, which means you utilize location 4 = 1. If the tag is not changing very frequent, maybe it only update like, let's say once a year, advice tag configuration is no good because you only have one data. You don't even have a data. You maybe have one data collect, and then 1 year later you get another data, right? So you have a long tail because it pushes update to the interface and to the Pi server. So that's why if you have a tag that is like not update very often, you should use pull tag configuration. Then you can do, in this case, you have a kind of a stale tags, right? Then you can pull every 5 minutes and make sure it's still the same. okay, look at it. Oh, it's still the same. Right? Then you have the numbers in your PyServer archive. Otherwise, you have a stale 1 years of data tags, and then I don't even know if it is going to malfunction for the advice tag. Like if it's stale for that long, and suddenly have one piece of data, and that will be a hard challenge to miss because you lose data again, because you cannot predict what is going to work. In summary, it just don't use advice tag if your tag is not updated frequently. Just use poll tag. But advice tag is easier to configure. Just put them all in location 4 equals 1 and then done. It will do the group, like a load balancing group for you, versus like in poll tag you have to I have to create so many scan class, right? Scan class 2 to like whatever numbers I want, and then try to do a split of every offset, right? Time offset, right? I'm trying to see how much I can do within one interface. That is like the way you kind of load balancing your tags within different scan class group to make it more performing, not having so many skip scan or skip missed, like scan miss. Like if it is like overloaded, right, it will have data loss as well. So you want to avoid that, right? Well, looking forward, what's the future? And what I see is nowadays more and more customer can configure OPC UA server as well, especially when they upgrade their DCS system or SCADA system. When they upgrade, they have an OPC UA server. Now they come to me like, oh, my OPC DA doesn't work. That interface, no longer works. Sometimes they even switch system, right? So they have no OPC DA. Now they go to OPC UA, and then they have to buy another interface, right? No. There's no interface for OPC DA, OPC UA. There's connector, Pi connector, and adapter for OPC UA. So when they have OPC UA as an only option, then they have to buy connector or adapter to collect the data, and it's different. It's not the same as what it used to look like from the interface angle. It's going to be more AF, right? For connector, right? You can, whatever structure you have created in your system of your SCADA system, right? Like if you have that hierarchy, it can replicate over to AF, right? It's kind of integrate with AF. Adapters is another newer data collection tool from Viva OSI Soft, so it can collect data from OPC UA. Yeah, I think OPC UA is the future. Thank you very much for watching, and please don't forget to subscribe as well as hitting the bell icon. I'll see you next week. Bye.